Hello coders, welcome back to my video. So in this video, we will be discussing about a very important topic when we are using libev is using libev in multi-threading. So till now we discussed that we use libev APIs in a single thread where we have a event loop and we have the watchers all in the single thread. Okay, so we need to now understand how to use libev APIs in multiple threads. Though your libev APIs is not thread safe, okay, but still we can use it by using lock mechanism in threads to access that APIs in multi-threading. And this thing is used in various, open source softwares. For example, OpenSync and other things. So let's start with this. So normally in libev, event loops run in one thread. So that we already discussed. You can watch my previous videos about libev. You will get to know. Okay. So the watchers, IO timers and asyncs are created and used in the single thread. Okay. So now in this video, we will follow these steps. Like we have two things. First is the event loop and second is the watcher or a callback that we use in thread B. Okay, so thread A is for only the event loop and thread B is for watchers or the callbacks. Okay, so initially, as a part of the example, we are taking only two threads. First is a event loop threads. This is an API we are using to create a thread and launching it with this API, which contain libev APIs. Okay, and second thread will be of the worker thread. Okay, and once the work is finished, we will send the async event to the event loop, which is running in another thread. So we have multi-threaded, communication in this example. Okay, so we will be sending the event to the event loop for processing it again. Okay, so this thing. So if you see here, we have the main thread that is the producer that contains some mutex logs and it will add the work. As to make this example a bit simple, we are using normal calls and not the queue. You can replace this producer with a queue as well. We will put that work in some queue and we'll take that work from the queue, but for simplicity we are not using queue here. So it will activate the event loop by using ev send. Okay, so once this work is done by the main thread, and the main thread here we are taking as worker thread, it will send a async event to the event loop. Okay, and event loop got the trigger, it will process the callback again. Okay, and the work whatever is produced by this worker thread is consumed by this event loop thread. Okay, so this is just a basic of this. So let's quickly jump into the example to get a more insight of this. Okay, so what I am doing now, I will be taking the main. Okay, so first, what I will write here, I will create two threads first. So for p thread underscore t, I have t1 thread and I have a t2 thread. Okay, this is clear. Then I need the mutex as well. So for that, I'll track p thread underscore mutex underscore init, and here we have address of log. Okay, and comma, then we have null. Similarly, I will take a conditional variable as well here. So take a condition variable here, and here we have conditional init. So for creating the thread, I will be using pthread underscore create. Simple as that. Okay, and what I need to put here is address of t1. If you don't know about thread programming, you can go to my videos to learn more about the threads. I'll post the link. in the description of this video. Okay. So next is a null, and then we have event loop thread. This is the API we created for the event loop. Okay, and null. Okay. So once this thread is created, I'll create a new thread T2 with the worker thread. Okay. So here I will put T2. So we have two threads. One is the event loop thread and second is the worker thread. Okay. So next I need to join this. So what I will do, thread underscore join. Okay. Then we have T2 comma null. Okay. So after this worker thread do some work, in the meanwhile, I'll take a sleep of 1 second and then I will do EV break to break the loop for the loop processing. So I have a loop and comma and EV break underscore all. Simple as that. And then I will take pthread underscore join, and here I will join my T1 thread, that is the event loop thread. Okay. And then at last, what I need to do, I have to destroy the mutex. So I'll take YY here and I will do mutex destroy here. Okay, for lock, and second is for conditional variable. Okay, simple. So now what we'll do, we have this lock and condition as a global variables. So this lock uh, and condition we put in the global area. So here I have lock and condition variable, and I also have an event loop as a global variable, so that both of the thread can use this global data. And we have a watcher as well here and work available like this. Okay, so I'll quickly go to first the main thread, that is the work thread. Simple as that. So what I have done here is I have this thread that is spawned and I wait for 2 seconds. Then I lock this thread. Okay. And then I am printing worker thread adding work. So for that, I just take work available variable as one. And then what I did was I just unlock my mutex. And after that, this variable got one as it is a global variable. So this value is there in the global variable, and the another thread, that is our event loop thread, should process it. Okay. So after that, I am using async APIs. So why we are using async? Because we are using multi-threading in our application. So this thread will send a async message to the event loop, and once this event triggers your, what do you say, as a second thread, your event loop got to know something has been changed and I need to process it. Simple as that. Okay, so this is worker thread. Okay, so once work is done, we have this variable as one. So let's go to the event loop now. So this is our event loop example. So this event loop is running in the thread. And what I've did, so this is common. Like we created a new loop. Okay, we initialize with async watcher, and we are giving a callback here, async underscore cb, and we are starting our loop, taking a watch on async watcher, and we are printing event loop started and EV. Simple as that. But the point to note here, we are only using the async type of APIs, not IO, not signals, EV signal, or any other. So async is just for inter-thread communication. Okay. So here this watcher is global. Okay, and this CB will switch to this CB what it is doing. So here, if you see, we locked it. Once we add our work, we send a async message, and then it will go here and check for the lock. So work done is already been one here after the worker thread. So it will check if work available is there. So as your worker thread runs before this thing, so this is already one. So it go inside and event loop thread processing work. This will print on the console, and then I reset this thing and again unlock it. So that will get more worker threads. Okay. So let's compile this. Okay. So if I compile it simply, so we are using pthread. So this library we have included externally, and for libev, we are using this library. Okay, so once I compile it, let's make it. Okay, so now if I run this libev thread, you will see event loop started, and now worker thread adding work, then event loop thread processing the work. Okay, so it will stuck here. So only one processing we have done, event loop has not been finished. Okay, so how to make it recursive? Next part is, so here if you see, we are only creating this worker thread once and then it will join. There is no loop here. It will send only one async event after this work done. That's why only one time it's printing. So what if I need to print it again and again? I need to add the work after 2 seconds. So what I will do, I'll take a while loop. Okay, and I'll put till here. So what it does, it will lock it. It will print this message. Okay, work available is one. Then it will unlock from there and send a event. So once it is processed, because this lock, whatever is there in the event loop callback as well. So it will lock it again. Okay, and then it will check the worker label, it reset this work and unlock it. So simple as that. So just taking loop so that it will run recursively. Okay, so if we again compile it and again run it, you will see event loop started, worker thread added, event loop processing, worker added the work. So this way it keeps on going after 2 seconds. So data is added, it has been processed. Okay. So this way we can have this libev working in multiple threads. So point here to note is, as we already discussed that it is this lead EV API, this EV run is not running continuously. It is waiting for some event to happen. It will trigger and then it will process this callback. So once this worker send it and it will send this async send, then this loop will be triggered, and after that this callback, whatever is there, it got processed. It's not by stone until some event is there. So this way we can handle the async communication between the threads. Okay. So thanks for watching this video. See you in the next video.